Hello, calculus. Well, this should be our last video. I know there's a lot of videos today. I know it's a lot to go through, but when we hit these bigger topics, we need to spend a lot of time on them. So here's hopefully a good introduction to derivatives for you. We'll do lots of them in class tomorrow so that hopefully you get really used to them and comfortable before we start moving on and learning all of our rules about them. And there are lots of rules. So we found the derivatives for these two guys in our work earlier. We found the derivative of this guy here is negative 2x minus 4. So you can go back through your work and find that. We also found that at negative 1, the value of our function here is negative 2 times negative 1, which is 2 minus 4. We said it was negative 2. And now it wants us to find the value as x goes to a of f of x minus f of a divided by x minus a, where a is the value of x. So in other words, for this one, I'm going to plug in negative 1 for a here. So I want the limit as x goes to negative 1 of f of x, I'm just going to write it out, minus f of negative 1 all over x minus a minus 1. All right, now that we know what we're finding, let's actually plug it in. So f of x would be this guy here. So minus x squared minus 4x plus 1 minus f of negative 1 is plugging in negative 1 for this guy. So minus a minus 1 squared minus 4 times minus 1 plus 1 all over x minus a minus 1 is x plus 1. So again, this guy here is just my f of x, which is this guy here. And then minus that same function, but we're evaluating it when x is negative 1. So this is going to be the limit as x approaches negative 1 of negative x squared minus 4x plus 1. And we've got lots of negatives happening here. Negative 1 squared is 1 times this negative is negative 1 times this negative makes it back to being 1. Negative 1 times negative 4 is positive 4, but this negative is going to distribute to it and make it negative 4. And then a negative times 1 is negative 1, all over x plus 1. All right, what does that boil down to? That's the limit as x goes to negative 1 of minus x squared minus 4x. And then I got 1 plus 1 is 2. Minus 4 is negative 2, minus 1 is minus 3, all over x plus 1. Hopefully you're writing smaller, because I'm running out of room in this box, so I'm going to have to flip it over. So the limit as x goes to negative 1. I still can't plug in negative 1, because if I plug in negative 1 into the denominator, I get negative 1 plus 1, it's 0, that's not going to be good. So let me factor out the negative sign. That make it x squared plus 4x plus 3. And then what can I do to it? Factor it, right? So this is going to be the limit as x goes to negative 1 minus x plus 1, x plus 3. That's this guy factored all over x plus 1. The x plus 1s will cancel, and now I can plug in that negative 1. So minus negative 1 plus 3. This is 2 times negative 1. This is going to be negative 2. Notice this guy here is the same thing that we said here. So we said the derivative at negative 1 is negative 2. And when I find the limit, the value of a limit at this one point, it is also coming at negative 2. Coincidence? I think not. She has started vacuuming the carpets out there, so I may have to cut this short and make another video, but hopefully not. All right, we found the derivative of this second guy here to be 1 over 2 square root of x plus 2. If I find the derivative at 7, or we did find it earlier, we said it was 1 over 6. All right, so we're going to plug it in. I'm just going to go straight into it. So the limit as x approaches 7 of f of x is the square root of x plus 2. Minus, sorry, I didn't mean to do that. minus f of a, that's when I plug in my a value into here. So minus the square root of 7 plus 2, all over x minus my a value, which is 7. So this is going to be the limit as x approaches 7. And the square root of x plus 2, 7 plus 2 is 9. Square root of 9 would be minus 3 over x minus 7. Can I put in that a positive 7? No, right. I get a 0 in the denominator. That's no good. So what are we going to have to do? You guess we've got a square root there. We're going to multiply by the conjugate. Square root of x plus 2 plus 3 over x, not over x minus 7, it's over the square root of x plus 2 plus 3. So this is going to be the limit as x goes to 7. The first guy times the first guy, we lose that square root sign. Our middle terms cancel out because they're conjugates. And then I get negative 3 times 3 is minus 9. All over x minus 7 times the square root of x plus 2 plus 3. All right, x plus 2 minus 9 becomes x minus 7. And notice now I can cancel them out, and finally we're at a point where we can plug in that 7. So nothing left on the top, so that just goes to 1. On the bottom I've got the square root of 7 plus 2 plus 3. Square root of 7 plus 2 is the square root of 9 plus 3. 1 over 3 plus 3, which guess what, folks? This guy, same thing that we came up with here. Starting to see a connection? So what inference can you make that explains what the limit, if we go to a specific point, and we use this version of the formula, represents? So hopefully you can see the connection that the limit, as x goes to a specific point, of x minus f evaluated at that point over x minus a, represents the slope of the tangent line drawn to the graph of f of x at x equals a. So that is what that guy means. So what we've explored today is we've got two different definitions, right? One is when h goes to 0, where we're making these 2 points get closer and closer to each other. And we said that that guy produces a function. How do we call, or what is our symbols that we use for this guy? F prime of x, right? That's our derivative at x. That can be used to find the slope of any particular tangent line drawn to f of x. So we use this formula if we're trying to find the equation of the tangent line so that we could use it to find maybe the derivative at multiple points. Whereas we're going to use this guy down here. This guy produces just a value, not a function, a value. What's a value? A number, right? It produces the value f prime of a. So what is my derivative evaluated at a? And we use this if we're just looking to find the slope of the tangent line drawn to the graph at that one spot. So drawn to the graph of f of x at x equals a. So if I were just worried about one point, and I want to know what's the value of the slope of the tangent line at that one point, then I use the alternate form Otherwise, if I want the equation that's going to tell me the slope of the tangent line at any point, and I can plug in different points for it, then I'm going to use that first definition. That is it for today. Tomorrow in class, we're going to do some exercises where we're going to find derivatives of both ways, and then we'll move on over the weekend. Have a good night, guys.